So here in this section in 8.4, we're going to talk about, I think there's 4 kind of rules, properties that we're going to talk about having to do with logarithms. Once we know these 4 properties, we'll use them some tomorrow in 8.5 when we start solving. So we need these ideas to use later. Now, what we're going to do is basically called expand, which means write it in the longest possible way, and condense, write it in the shortest possible way. Now, really the point of this is to just get the idea of what these rules are so that we can use them when we're solving in 8.5. Now, the first rule is called the product rule. I think you'll see why it's called, and I don't know why all these things are popping up, but I think you'll see why it's called the product rule. Now, I'm just going to write out the rule with variables. I'm going to call my base B for base, and here I'm multiplying, hence the name product rule. Product, answer when you multiply. When you've got 2 numbers multiplied inside a logarithm, you can split them apart into 2 logarithms, keeping the same base, added together. Now I want y'all to look at what I have here. See how they're multiplied inside the logarithm? I split it apart into 2 separate logs, same base, with the first thing in the first term, the second one in the second log. So I'm just going to look at a few of these. So here I have log base 9 of 9 times x. So if I were to expand this, I could say, well, log base 9 of 9 plus log base 9 of x. Now that's great, but I'm pretty sure I can do better than that. Now y'all think shortcuts, back to the last section. If these 2 numbers match up, what's log base 9 of 9? Remember, if the numbers match up, the whole thing is 1. Okay, so that's expanding, which means we're taking it and we're like making it bigger. We're going to go backwards here and condense. Now remember, if it's addition here, it's like I'm starting on this right-hand side and coming back over here. So with the addition sign, I'm going to combine it into 1 logarithm with multiplication, or log of 10. Now y'all remember, if there's not a base written, it's understood to be base 10. I can simplify this because see how those match up? Shortcut, log base 10 of 10 is 1. Alright, so first rule, called the product rule. Here's the second one, it's called the quotient rule. And it basically says the same thing, except instead of multiplying, I'm dividing. So there's my division. Now again, I call the base B. I picked some letters to use here. Now with product rule, when we were multiplying, we split them apart with addition. Now when we're dividing, we're going to split them with subtraction. Now I want you to notice here that what's in the bottom of the fraction is what's being subtracted, is what the negative belongs to. So just keep that in mind because we're going to have a little bit of a combo here in a couple of minutes. Alright, so I have log base 7 of 7 over x. So I'm going to split it apart using subtraction. And I hope you caught it. What is log base 7 of 7? Remember, if these match up, it's 1. Alright, so that is quotient rule. Let's go the other direction. We expanded. Let's condense. So you'll notice these are separated with subtraction. So I'm going to combine them with division. Now I didn't write a base here because it doesn't have one on either of these, which means it's understood to be base 10. Now I can't simplify that, so I'm done. I could combine it into 1 logarithm, but I couldn't really do anything from there. Alright, so that's the quotient rule. Our next rule is called the power rule. Now let me go ahead and write it out. This one sometimes makes more sense when you start seeing numbers. Now we don't have an n in this one, but our m is going to be raised to a power here. So I'm using p for power. Now here's what the power rule says. It says if you've got an exponent inside your logarithm, you can pull that to the front. So this right here equals p log base b of m. Okay, so it's called the power rule. So if I ask you to expand log base b of x to the third, you can move that 3 to the front. Now this can save you a lot of grief in some of your solving later on, so just remember this power rule. Okay, now I want to remind y'all of something, so we're going to expand another time. Remember, if you've got a radical, and this goes back to last chapter, if you've got a radical, you could rewrite it as a fraction exponent, so 1/5 power, which would then allow me to pull that to the front. So 1/5 log base 3 of x. Okay, now before we move on to our last rule, which we're going to use the calculator a little bit for, I want us to just look at a couple more of these where we're kind of doing a combination of a couple of rules. All right, so on this one, we are condensing. Now I want you to notice two things. First of all, I've got this 5 out front here that I'm going to move up to the exponents. I've also got subtraction. Subtraction means I'm going to use the quotient rule, division. All right, so I'm going to start by moving those numbers back up into their exponents. So natural log of x to the 5th minus natural log of y squared. Now that's great. I've gotten it sort of halfway done. Now because of the subtraction, I'm going to combine it with division. Now it's natural log, remember that means base e. Okay, now this was condensing. We grouped it all into one logarithm. Now we're going to go the opposite direction. I've given you one all in one logarithm. I want us to expand it. So when I look at this, I've got two things multiplied together. I've got the x squared times the y. So I'm going to start by using the product rule, which means I'll split it with addition because it's multiplication in the problem. Now that's great, but I can do more. I'm going to pull that 2 to the front. There you go. Okay, now here's the last one we're going to do before you look at this last property that's a little different from the others. This is the one I was going to skip. Okay, now here's the reason I wanted to do this one. If you look at this, now there may be some other stuff in here that I haven't gotten to yet, but there's a combination of product, multiplication because of the addition, and quotient here. You've got a combo of the two. Now I want to remind you, in the quotient rule, let me go back to it. Oh, there it was. In the quotient rule, whatever's in the denominator is what's subtracted. So I'm going to remember that here, if I can find it, here. What's subtracted goes in the denominator. Everything that's positive, this is like a positive here, positive here, positive here, goes in the numerator. Okay, so I have log, understood base 10, of x times 7 times x squared minus 1 all over x plus 1. Okay, now I want you to think about this for a second. I put the x plus 1 in the denominator because it's negative. The other ones are positive. That's why I put them in the numerator. Now, this is great, but I'm pretty sure I can do better. So I'm going to simplify a little bit. First of all, I don't really like it written as x times 7. Who writes it like that? Only people who aren't as mathematically inclined as us. So I'm going to rewrite it as 7x. And then I'm going to go ahead and factor that. Now I want y'all to look at why I would factor it. See how by factoring my x squared minus 1 difference of perfect squares, it will allow me to cancel out the x plus 1's. That just leaves me with log of 7x, x minus 1. And I think I might put that in brackets or something just to make sure it's all inside the logarithm. Now, just as a reminder, there's no base written on any of these, which means it's the common log. Common log means base 10. So if a base isn't written, it's understood to be base 10. All right, now we've talked about 3 out of our 4 rules. The last one, I'm going to tell you, you guys are going to love. All of you calculator addicts are going to say, I love this last rule because it's going to allow us to use our calculator more. So here you go. This is called the change of base property. Now I want to remind y'all of something on your calculator before we come back and talk about this. Now y'all remember, on our calculators, there's only 2 logarithms that we can do in our calculator. We can do, here's my cursor, we can do regular log, which is understood to be base 10, so we can do log base 10, and we can do natural log, here's natural log, which is log base e. So we can only deal with log base 10 or natural log, which is log base e. Nothing else. Log base 2, log base 5. We can't do those in the calculator. We just can't. The calculator's not programmed to do that. What the change of base property is going to allow us to do is change the base to anything we want it to be, which means in our case, where's my calculator? Which means in our case, I'm going to choose either base 10. I can use this button on my calculator. Or I'm going to choose natural log base e. I can use that button on my calculator. I'm going to pick something that I can do in my calculator. All right, here's the property, and then we'll look at a couple of problems. So I have kind of same setup before. Now this will allow you to change it to any base that you want. Now we're going to choose base 10 or base e, or it doesn't really do us any good. But I'm just going to change it to base A, which means it could be base E, it could be base 10, but here's how you do it. The top of your fraction, I'm going to put a fraction here in a second, is log base, whatever you want it to be, to the m of the m, over log base A of the old base. Now see how this can be whatever base you want it to be. Now I want us to do 2 of these in our calculator. So we have log base 5 of 13. I'm going to change it to something I can put in the calculator by saying log of 13, log base 10 of 13 over log of 5. Now I could also do this using natural log. So I could also do natural log of 13 over natural log of 5. Now usually I would get you to put 1 in your calculator and I'd put 1 in my calculator, but since you're just watching me, let me put these in my calculator. What I want you to see is I'm going to end up with 1.6 here. Let me put that in my calculator. I want y'all to see what we'll get. Natural log of 13 divided by natural log of 5. Ooh, exact same number. See how you can use either of these? It doesn't matter, it's your choice. Pick one. Probably don't switch back and forth unless you're a weird math teacher like me. Pick one and kind of stick with it. All right, so last one of these. I'm going to use base 10. If I want to change this to figure out what it is in my calculator, I would take log base, whatever I want, I'm going to use 10, of 57.2 over log base 10 of 16. And I'll put that into my calculator. So log of 57.2 divided by log base 10 of 16, which is 1.5. All right, now I wanted to show you a little bit with the calculator and kind of changing the bases here. I do want you to remember we will have a calculator and a no calculator part of test, so make sure you're not dependent on the calculator. At the same time, I want you to be able to use your calculator as well, so make sure you can do things with or without your calculator. All right, so this is 8.4, which is properties of exponents, and we will stop right here.